Thank you so much, Joe. And then he's going to be talking about reputation on the data layer.
Hi everyone, cool. This is Microsoft. Good to be here in Paris. Always fun to come back here every year. I think it's the first InfraCon here though, so exciting to meet all of you and chat about Web3 infrastructure. Today I'm going to be chatting mostly about reputation and how we can make reputation much more legible in the Web3 world. I think we're starting to see some people and parties going in this direction, but I think there's actually quite some way to go still. So let's look at it. So first of all, what is reputation? Well, I think reputation is something that's been with us almost like longer than we have language. We've always like looked at the type of actions other people have taken and built internal models in our minds about like what we think of these other people and how we would want to interact with them. So in this example of a marketplace, you have traders and buyers and sellers. They all kind of like build an understanding of like who they actually want to trade with internally. And over time, this has become more sophisticated. We've started taking notes. We've started maybe like having separate entities that run like different sorts of algorithms over the data that they capture. We've seen this also now in the Web3 space, where in blockchains we're actually recording a lot of like financial data. But if you think about it, financial transactions and financial data is not really the only place we use reputation. We also use reputation essentially everywhere, especially in like social scenarios. And so how can we expand the reputation in Web3 from only being this like financial thing to being something that's more universal and we can use for all different types of applications? And I think the basic building block of reputation is really a claim. So a claim is basically a statement that you make about something or someone. And this could be like you saying that someone did something good, or just an action that you take online. Maybe it's like making a comment or something like this. In order for this claim to be something that's actually useful in the context of Web3, we need to have some sort of attribution of like who actually made this claim. And normally this takes the form of a digital signature. Another thing that's important is making a claim, or is knowing when this claim was made. So having the attribution of like when it took place. And normally this can be done with something called proof of publication, which is essentially using a decentralized ledger and publishing either the full claim itself or the hash of the claim on chain. And okay, so like how do we actually make these claims technically? Well, there are different types of signed claims. We can see that like an Ethereum transaction in general is a claim. It can do a lot more than just like claiming something about someone or something. But in the case of like just a plain claim, that might look something like a soulbound token, where it has some data and has some owner and the issuer. But these are of course like on-chain and fairly expensive. There's a lot of things we can do off-chain. So sign type data, ERC 712, not to be confused with 721. Is a way to sign structured data that has a particular schema. And this happens in the user's wallet. They get a pop-up, they see what they sign, and this is of course free. But it doesn't include any information of like when this thing happened. Then we have an improvement, I think, on this, which is signing with Ethereum plus cryptographic session keys. And this also is off-chain, it's also free, and it also needs some way of timestamping, but we get much better UX. Essentially, a user can come to your application, the application can generate a session key, and the user basically just needs to sign into Ethereum once, and that signs over the session key, gives essentially this key permission to sign on your behalf over the course of some time. Maybe that's a day or maybe that's a week. And so you can have really kind of user experience that people are used to in Web2 applications, where they kind of sign in once and then just like use the application, while still having strong cryptographic attribution to all the things that the user did in the application. All right, so now that we have all these like off-chain claims, where do we actually store them? And I think there's been a lot of discussion recently about like, let's just store everything on-chain. Because that makes everything easier, we get timestamps for free, and we can just reference this data whenever. And this is lovely, but it's kind of like expensive, right? Like if we were to put it on Ethereum, we're kind of limited by the block size currently, which is, I think, 1.8 megabyte if we pay the maximum gas fees, which we probably won't be able to do all the time. And all data here is public, and the nice thing is like anyone can verify this data, and it's available to all people running nodes in the network. Beyond just like current L1, we can go to Ethereum has this plan to create danksharding. The best information I could find online was like blocks will probably get up to like 32 megabytes. Okay, that's a big improvement, but the order of magnitude of like actual signed claims we want is probably way bigger than this. And in danksharding we have L2s, right? We have all the data that's made available at the same time, every block. But can we go beyond this? And this is what I think is the data ledger. The data ledger is essentially a decentralized network where data is produced in parallel. So all nodes don't need to kind of validate the data is available in sequence, but can just validate a subset of the network. And this data can sort of be conditionally on-chain. Since it's signed and since it's potentially timestamped into the blockchain, we can actually create proofs of this data and put it on-chain if it's needed. And since we have this way of segmenting the network into arbitrary pieces, we can get unbounded throughput. And potentially one thing we can do that we can't do with blockchains is actually do some sort of physical access control. So we can have subsets of the network that actually runs within a subset of nodes without revealing it to the entire network until we might need to prove some aspect of reputation on-chain. Okay, so how can we actually see if something is a data ledger? I think these are the properties that are needed. So we need something where we have really high scalability throughput without sacrificing decentralization. And what I mean when I say sacrificing decentralization is essentially the value that the Bitcoin and the Ethereum community is promoting a lot, which is like, I need to be able to run a node on commodity hardware. And in Ethereum and Bitcoin, you solve this by just like limiting the throughput. I think in the data ledger, we can solve this by essentially having individual nodes be able to synchronize subsets of the network and validate that fully without having to care about the entire network. I think besides that, we need to also timestamp things on-chain. We can rely on the blockchain security for when things happen. And if we have this, I think can be, basically if we have this structure, we can have the property that it's objective to verify that, okay, this was signed by these entities or these accounts, and we can verify this without trusting any third party. And this essentially means that we, in theory, can verify it on-chain as well. And Ceramic, the project I'm building, is essentially a data ledger. It has an event stream-based architecture. And you can think of all the data that's written to Ceramic as being in this huge range. You can think of this circle you see on the right side here as being all of the data from all of the data streams from 0 to Z. And nodes can join the network and synchronize any subset of this range, do the entire range or down to an individual event in the network. Ceramic timestamps to Ethereum, so we use the security of Ethereum to get a sense of time in Ceramic. And since we do this timestamping and we do signatures that are bound to Ethereum addresses, we have really strong attribution. So we can use this network, look at the data, run potentially different types of aggregation algorithms, and build different types of reputation scores. And I think one of the things that's really important when we think about reputation is the ability for anyone to create reputation scores. We don't want to rely on like one reputation protocol that basically wins the market, and like that's how we do reputation now on planet Earth. Like that's just not aligned with the values that we care about around plurality and so on. Right now, Ceramic is for public data and encrypted data on Ceramic. But we might potentially explore also like ways to do physical access control to the data stored and notarized in Ceramic. Okay, so how do you actually use this if you're building an application? To make it easier, we created a database called ComposeDB. ComposeDB is the first database built on top of Ceramic. It basically is like indexes a bunch of event streams on Ceramic and creates and then puts them into an index database. And the neat thing here is that it uses natively sign in with Ethereum and these like cryptographic session keys. So from a user's perspective, using an application that is built on ComposeDB, the user comes, signs in once, and then can just use the application as a normal app. For a developer, you can create data models using GraphQL. This is something that a lot of Web2 developers are really already familiar with. And not only can you model your own data, but you can actually browse the existing ecosystem of data and models that have been created, and you can pull that into your application. Whether that's like someone already made like a commenting model that makes it easy for you to like integrate a way for people to comment and discuss things in your application, or if it's actually a bunch of data you've seen people build up that you actually want to ingest into your reputation algorithm. All right, so I think with these basic building blocks, we can actually start to build a really large-scale reputation ecosystem for Web3. Thank you.
Thank you so much, Joe. So anyone has questions for Ceramic? No? Well, if you have a question in the future, make sure you drop in the chat, or you can contact Joe just directly in the Telegram group. Thank you so much.